Alright, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you're going to have x minus 6 times x plus 4 for your answer. For the math knowledge question, it asks us for the c value, and it tells us that we have these 2 points. And so you can just plug these two into your equation. So when our y equals 0 here, our x value is negative 2. And so we end up with negative 2 squared is 4 plus 8 plus c. So that would give you a c value of negative 12. And you can check it also with this point here. So when y equals 6, your x value is when y equals 0, your x value is 6. So if you plug in 6 to your equation, you get 36 minus 24, which is 12 plus c. So c again equals negative 12. So that would be the value of that one. So that's one way you can do that one. Just plug in one of the points that they give you to find your c. Okay, so we are looking at lesson 13 today. We're doing inverse trig functions and then trig equations. We dealt with these in pre-calculus last year, so hopefully the inverse trig functions and the trig equations will actually be reviewed for you. This is a pre-calculus concept, not really so much a calculus concept. So these are all 3 different ways that you can write inverse trig of sine. Arc sine of 1/2, sine to the negative 1, sine inverse, or inverse sine. Any of those, they mean the same thing. Do you remember your graphs for sine, cosine, and tangent from last year? Your domain for sine is from negative pi over 2 to pi over 2. And for tangent, it's also negative pi over 2 to pi over 2. But for cosine, it's from 0 to pi. So I'm going to write that out for you. For sine, it's from negative pi over 2 to pi over 2. For tangent, it's from negative pi over 2 to pi over 2. And for cosine, it's from 0 to pi. So these are for your inverse trig functions. Negative pi over 2 to pi over 2 is the 4th and the 1st quadrant. So that's where sine and tangent happen. And then for cosine inverse, it's from 0 to pi, which is the 1st and the 2nd quadrant. So that's for cosine. So your answers, you're only going to have one, and it's going to either be in the 1st and 4th if you're sine and tangent, or in the 1st and 2nd if you're cosine. And so these 3 graphs right here, y'all need to graph. You may, actually you will need to know those for a test. I'm not sure which test, but they do ask you to graph those. So y'all can pause the video and graph them. What I'm looking for on your graphs, on your tests, are going to be negative 1 to 1, negative pi over 2, pi over 2, and the shape looks accurate. So on this one, I'm going to need negative 1 to 1. I'm going to want your origin, pi over 2 and pi, and that the shape looks pretty accurate, and that it's going through this point right here. And then for tangent, your endpoint, negative 1 to 1, negative pi over 2 to pi over 2, and then the graph with arrows, whereas these have dots, and then your asymptote graph there. Alright, so we want to evaluate sine inverse of square root of 2 over 2. So basically what you're looking for, what angle for sine gives you square root of 2 over 2? The sine of what angle is square root of 2 over 2? That's basically what this is asking for. So your angle, where it equals square root of 2 over 2, you want these in radians. So you may be thinking 45 degrees. Hopefully you are. That is correct. but it wants it in radians. And so the radians of pi over 4, of 45 degrees is pi over 4. And so that would be your answer. Now, yes, there is another place where sine does equal square root of 2 over 2, but that's not in the first or fourth quadrant. That's going to be in the second quadrant. So we would only want to use this first quadrant answer. Looking at this one, cosine inverse of negative square root of 3 over 2. What angle is going to equal negative square root of 3 over 2? So first, let's look at the cosine of what angle equals square root of 3 over 2. Let's start with this one. That angle, any ideas what it's going to be? You should hopefully be thinking 30 degrees or pi over 6. However, in the original problem, there's a negative. So we need to look at the negative. Now for cosine inverse, we're only going to be in the first and second quadrants. The first quadrant is where it's positive. The second quadrant is where you have negatives. So the negative is going to pop us into the second quadrant. So a 30-degree angle in the second quadrant, if we're looking in the second quadrant, we have 30 degrees here. To get there, we had to go 150 degrees. Or if you put 150 in terms of radians, you would have 5 pi over 6. And so that would be your answer there. Okay? So now we're going to look at some trig equations. So we want to solve secant of x equals negative 2. And on this one they tell us our answers need to be in degrees. So I'm not as familiar with my secants, but I do know my cosine, which is the reciprocal of secants. So if I replace secant with its reciprocal, which is cosine, I can also take the reciprocal of negative 2 and make it a negative 1 over 2. If you don't like doing it like that, you can make secant 1 over cosine equals negative 2, and then if you cross multiply, you would get 1 equals negative 2 cosine of x, and then divide by negative 2. And so cosine of x equals negative 1/2. So you still get the same equation. It's just a little bit more work here. So you can just do the reciprocal. Secant reciprocal would be cosine. Reciprocal of negative 2 is negative 1 over 2. And so then we're looking for everywhere in between 0 and 360 where cosine equals a negative 1/2. So cosine of x equals a positive 1/2 when x is 60 degrees. But we're looking at negative 1/2. Cosine is negative in, let's go back to this real quick. It's going to be negative in the second and third quadrants. And so a 60-degree angle in the second quadrant would be 120, and in the third quadrant would be 240. And so that would be your answer, 120 and 240. Okay, looking at this next one. All right, so for this one, there are two ways you can do it. You can either move the 1 over and set it equal to 0 and factor that. And so you would have sine of x minus 1 times sine of x plus 1 equals 0. And then sine of x would equal 1, or sine of x would equal negative 1. Or you can just take the square root of both sides. And so the square root of sine squared is just sine of x, and the square root of 1 is plus or minus 1. So either way you'll get the same thing. So we're looking where sine is equal to 1 and negative 1. So that's where you're going to go back to your quadrantal angles. It's either going to be one of these 4 or 2 of these 4. And so this point is 1, 0. This point is 0, 1. This point is negative 1, 0. and this point is 0, -1. And so your sine is your y value, and so this is where our sine is equal to 1 and -1 at 90 degrees and at 270 degrees. But if you look here, if we put 90 degrees and 270, that would be wrong because it wants our answer in radians. So we should put pi over 2 and 3 pi over 2 for your answer. Okay. So now we're going to look at another one. On this one, you can't do both methods that I just showed you because, or you could, it just doesn't factor quite as simply as you would think. So for this one, I would just take the square root of both sides of your equation. And so the tangent of x would equal plus or minus the square root of 3. And so we need to figure out where tangent equals square root of 3. That's going to be a 60-degree angle. And where else does it equal either positive or negative square root of 3? It's going to be 1 in every quadrant. So 60 degrees in the first quadrant would be 120 in the second, 240 in the third, and 300 in the fourth quadrant. And so those are your 4 answers for that one. Looking at another example, this one's a little bit different because it's in terms of cosine and sine. So you have to make a replacement. You need them all in terms of the same trig function. So the way that we're going to replace this one, we know that cosine squared is equal to 1 minus sine squared. And so we're going to make that equation, and then I'm going to move everything to the right side so that my sine squared is positive. And so 1 minus 2 is -1. When I move it over, it's going to be a +1. So that's the equation that you'll have once you make that replacement. That's from your Pythagorean trig functions. Cosine squared plus sine squared equals 1. So then this will factor as sine of x minus 1 times sine of x minus 1, or you can make it sine of x minus 1 squared. Either one is fine. Both of them are going to give you where sine of x equals 1. And so if you look back at your quadrantal angles, the only place where sine of x equals 1, and we're in degrees here because of this up here, the only place where it equals 1 is at 90 degrees. So that's your answer for that one. Okay, we're going to look at one more example. 2 sine squared of theta equals 3 plus 3 cosine of theta. We again need to get them all in terms of the same one, so we have to replace this sine squared with something. So sine squared is the same thing as 1 minus cosine squared of theta. And so then you're going to want to distribute the 2. And so then you're going to move the -2 cosine squared theta to the right side to make it positive. Then we have plus 3 cosine of theta. And then when we move the 2 over, that's going to become a 1. And so some of you may be a little bit unsure how to factor this. If I make it look like this, that may help you a little bit. Replace the cosine with an x and a cosine squared with an x squared. You're going to use your move, replace, reduce. And so you can factor it using x's and then go back and replace the cosine, but I'm not going to do that. I'm going to actually use the cosine so that you can kind of see what it looks like. So we're going to make it cosine squared theta plus 3 cosine theta, and then plus 2, because we're going to remove the 2 and multiply it with that 1. And then if you factor it, we're going to have cosine of theta, cosine of theta, and you're going to have plus 2 and plus 1. And then we're going to replace the number we took out, which was a 2. And then this one doesn't reduce, but this last one does. So we have 2 cosine of theta plus 1 and cosine of theta plus 1, because both of these can divide by 2. And so that's how this equation factors. And then you'll set your 2 factors equal to 0. So this is going to become cosine of theta equals negative 1/2. And over here, this one is going to become cosine of theta equals negative 1. And then we need to figure out what degree angles, because it's in degrees, does cosine equal negative 1/2. Cosine equals 1/2 at 60 degrees. So negative 1/2 would be 120 and 240. And then for cosine equal negative 1, you're looking at your quadrantal angles. Cosine is your x values, and so the x is negative 1 at 180 degrees. And so those would be your 3 answers for this one. So hopefully you remember doing those last year with pre-calculus. There are different types of trig equations that they'll give you, but those are the basic ones that you'll have. So on your homework tonight, you need to make sure to do 1 through 25, and then we can go over any questions you have tomorrow.